pulley systems here. When we have two or more pulleys working together to perform a certain task, then we call that a pulley system. When you have only one pulley, it is still a pulley, but when you have two and above, that one constitutes a system. Like here, you can have actually a number of arrangements which you can use to enable the pulleys simplify the work. Remember, pulleys are machines. Now, this one is one of the arrangements. There are various arrangements you can have, and particularly looking at this one, the wordings here are saying that for B to move upward a distance x, the distance x has been indicated there. A length 2x of the string must pass over the pulley A. And how does this one move up? It is by having x, a force put at x, moving downwards. So if this one moves up and at a point when it is really up here, it means that the whole length, this x plus this x here, has moved through that. That's how it is coming to 2x. That one is supposed to mean that if the pulley is moving up with an acceleration A, this side will be moving down with an acceleration 2A. And we are going to use that consideration in solving some problems to do with the pulley systems, especially those which are containing this arrangement. Each arrangement is going to have different ways. It is going to require different renderings, but as far as this arrangement is concerned, that's what we have. If this one is moving downwards with A, this one goes up with 2A. You may never know. You may have a case where the pulley is heavier than whatever is that side, and this one may need to move downwards. So as this one moves downwards at A, this one goes up with 2A. If this one goes up with A, this one goes down with 2A. That is what you need to take note of. We shall illustrate it with an example. Let's look at this example. A string with one end fixed passes under a movable pulley of mass 4 kg and over a fixed pulley and carries a 5 kg mass at its other end. What is the acceleration of the movable pulley and the tension in the string? Acceleration of the movable pulley and the tension in the string. This one is the diagram I've made. It is not part of the question, remember. You are supposed to extract this diagram from these wordings here. So they said a string which is with one end fixed. This is the fixed point of the string. Passes under. It is like this. It is passing there under. That is it. And then this is the movable pulley, and then over a fixed pulley and carries a load. Carries a 5 kg mass at its other end. That's the scenario we have. This one goes up, this one comes down. With this one as A, this one is 2A. So what we are going to do, we shall consider motion of each movable object. We have the 4 kg pulley which is moving upwards, and this one moving downwards. So consider the motion of the pulley and also consider the motion of this one. So we start from the pulley. Consider motion of the pulley. If the pulley is supposed to move upwards, it means that the tensile forces, this one and that one, which is T and T. So you have 2T acting upwards minus the 4G which is acting downwards, of course, which is less than these two combined, should give us the mass of the body, which is 4 times the acceleration of the body. That is, we can call that equation 1. Then consider the motion of the 5 kg body. So for 5 kg body, it is moving downwards. So 5g minus that, it is moving downwards. So the weight will be bigger than the tension. So I have 5g minus t is equal to the mass, which is 5, times the acceleration of that body, which we are saying that it is 2a. And we can rewrite this one as 5g minus t equal to 10a. This is the one we are preferring to call equation number 2. And we need to solve those two equations simultaneously. Let us get equation 1 and we add it to 2 of equation 2. Because when we do that, we shall have a 2t here, which is negative, and we add it to a positive 2t, and we shall be eliminating the t's. So when we work out that, like the way we have suggested here, we shall have 4g, which is negative, plus 2 times that is 10g. So you have negative 4g plus 10g, that one is 6g, and that is on the left hand side. And on the right, 2 of this one is 20 plus the 4, that is getting us 24 times a. This means that a is equal to 6g over 24, which is equal to 1 over 4g. We can have that a is equal to, when you substitute the value of g, you get 2.45 meters per second squared. And when we use equation number, let us use equation 2. If you try to make it the subject of the formula, we are taking this t to the right, then we turn the equation around. Shall have that t is equal to 5g plus this one is a minus 10a, but a is 2.45, and g, the t, is equal to, substituting that, maybe let me say this, 5 times 9.8 minus 24.5, shall have that t. When you get this one is 49 minus that one, we shall have the final thing as 24.5 newtons. This one happens to be another arrangement of pulley system. If you look at this arrangement, it is somehow different from the one we have just handled, because this one bears 2 fixed pulleys and we have one movable pulley. And now what we are going to look at here is the fact that if I have there is a point x and a point y, if it happens that the point x is moving at acceleration a1 and point y moving at acceleration a2, both of them moving downwards, they shall be pushing this pulley upwards at any acceleration which is equivalent to the average of the accelerations of the other two. Because if this one moves a distance x downwards and this one moves a distance y downwards, this one here will move a distance which is the average of the other two upwards. So we are getting the accelerations from the displacements that can be created by moving these points downwards. We can get an example to illustrate this, to apply this concept here. This example is going to apply the concept we have just talked about. A pulley system has loads 6 kilograms and 3 kilograms at the ends of the string, and the movable pulley has a mass of 2 kilograms as shown. The diagram is here. This diagram is part of the question. That's why they are saying as shown. Then they are saying that assuming pulleys to be smooth, that is a very good assumption. Find the acceleration of pulley C. Find the acceleration of pulley C. Now we look at this one. You see that this one is 6, this one is 3, and this one is 2. It is not easy for this pulley to move downwards when this one is 3 and this one is 6. So most likely this one shall move downwards and this one also downwards, so that the pulley shall move upwards. Let us indicate some forces here, because there are some forces involved here. There shall be a downward force of 3G acting downwards, and there will be a tensile force in that string acting upwards, and respect to the pulley there is that T also. Respect to this pulley there is T, there is that T there. We are assuming that T is the tension in the string. It is a constant tension because the pulleys involved are smooth pulleys. This pulley, there will be a weight. Its weight will act downwards. It is 2G, and there is a weight 6G for the 6 kilogram body acting downwards. Now this one is that shall have that this one has acceleration A1, and this one moves downwards with acceleration A2. That one shall call for this to move upwards at acceleration A1, a half of A1 plus A2. So our concern is to get the value of A1 and A2 so that we can substitute it in this formula to get the acceleration of the pulley. Now we are going to consider the motion of each particle by particle. 6 kilogram body individually. Take the pulley, take the 3, and we consider their acceleration is, and we solve for what is required of us. So we are going to say that for 6 kilogram load, you see it is moving downwards. So it is supposed to have that we are supposed to have that the weight is bigger than the T. So you have 6G minus T is equal to MA, which is 6 times A1. The mass is 6, the acceleration is A1. This one is the resultant force on that body because it is acting downwards. There is a 6 down and a T up. That's what we have. We are going to call this equation number 1. Then we have for pulley, for 2 kilogram pulley. For 2 kilogram pulley, the pulley is moving upwards, so the tension is this T plus that T, that is 2T upwards. So you have 2T minus the weight of the pulley acting downwards is equal to a half of, actually it is equal to, it is supposed to be MA. And what is the mass? The mass is 2. What is the acceleration? It is a half of A1 plus A2. And before we call this one equation 2, we can try to work out that this one is 2T minus 2G equal to A1 plus A2. That is the one we are going to call equation number 2. And after that, we also consider motion of this. And for this one, it is moving downwards, and its acceleration is A2. So we have that 3G, this one is 3 kilogram mass. You can call them mass, you can call them load. And so we have that it is acting downwards, so the weight is bigger than the tension. So you have 3G minus T is equal to 3 times A2. This one is equation number 3. Our task now, this is the diagram. I'm done with the diagram. So what our task now is to solve these 3 equations for the values of T, A1, A2. There are three unknowns, and since we have three equations, we can solve the three unknowns. But for this particular question, they have told us to just find the acceleration of the pulley. So we don't need to find the value of t. What we are going to do, we are going to eliminate t between 1 and 2, then eliminate the same t between 3 and between 2 and 3, and remain with no t. We shall have two equations with no t, and we solve those ones. We have 2 times equation 1 plus equation 2. That one can enable us to eliminate the value of t. So 2 times this one, that is 12, plus this one, that one is 10g. So you have 10g on the left hand side, because when it comes to t, you have a negative 2t and a 2t, which is positive. Then on the right, this one is 12, because we are multiplying every term here by 2. Remember, multiply this one by 2. So we have 2 times that is 12a1, and we are adding on this one. So we have this one is equal to 13 of a1 plus a2, because there is an a1 here. 12a1 plus this a1, that is 13a1, then this a2. We can call this one equation number 4. The next thing we are going to do, we are going to get equation 1, and we subtract equation 3. That way we can eliminate t from there, because there is a t here which is negative and a 2 which is negative there. So by subtracting the two equations, we shall be eliminating t. So we have subtracting there, that one is 3g on the left. On the right we have 6a1 minus 3a2. This one we can reduce by 3, and we have that g is equal to 2a1 minus a2. Call this one equation number 5. Let us have equation 4, and we add to equation 5. There we shall be eliminating the value of a2. Left hand side, 10g plus g, that one is 11g, is equal to 15a2. And that way, the implication of that is that a2 is equal to 11 over 15 times g. This one is in meters per second squared. After that, we can use equation, let us use equation 5 from equation 5. We have that a2, we are taking a2 to the left hand side and g to the right. This one is 2a1 minus g. This one is 2 of 11 over 15g minus g. This one is 22g over 15 minus g. And when you work out this one, you are going to get 7 over 15g. This one is in meters per second squared. And now we shall say that pulley C has an upward, actually it is an upward acceleration, because all of the values are giving us positive. Has onward acceleration which is equal to a half of a1 plus a2. This is a half. A1 is 7 over 15g plus, okay, let me put this is a1, 11 over 15g. 11 over 15g. So a2 plus a1, addition is commutative. So this one is giving us, if you work out with this, there is a 9 here, After going with these two, then 9 by 3 have 3, so this one is 3 over 5 g meters per second squared. We have this one is another form of arrangement we can have for a pulley system. Here we have a movable pulley, a pulley A, which they are claiming that it is a light pulley. We shall not argue with them, but they are saying it's a light pulley. And as you can see, when you look at this diagram, you see that this one is 3 kilogram. The pulley is light, but there is a 6 kilogram mass and a 2 kilogram mass. This one must be moving downwards. The right hand side should be moving downwards, and this side will be moving upwards. We are calling that acceleration A1. So this side upwards A1, this one downwards at A1. And then I will look at this pulley again. There is 6 and then 2. There shall be some bit of motion about pulley A, because this one being heavier than that, there will be some bit of motion like that. So this one shall be moving again downwards. If we talk about that acceleration as A2, if this one moves downwards at A2 relative to pulley A, A2, this one also A2, then we can have that form of motion. But we are saying that when we have a system like this, we are going to consider the relative acceleration is, because this one is relative to this pulley, we have that acceleration. But what really is the actual acceleration of this 2 kilogram body? And what about the actual acceleration of this? We are saying that if this one is the acceleration, we have it here, that in the system shown, if the 3 kilogram load ascends with an acceleration A1, the pulley A descends with an acceleration A1 still. A1 upwards, A1 downwards. And suppose the acceleration of the 2 kilogram and 6 kilogram loads relative to the pulley A are A2 upwards and A2 downwards respectively. That's our supposition. That relative to this pulley, this one is moving upwards with the acceleration A2, and this one downwards. Of course, this one is a connect. These two are connected, so they move at the same acceleration because they are connected by the same string. So we have that relative to pulley A. Now, how we have that? The actual acceleration is of these loads will then be, this one is A2 minus A1. In your document, the one you got from Telegram channel, it was indicating A1 minus A2. That one is not okay. You write A2 minus A1. And so this one will be moving upwards, but its acceleration will be A2 minus A1. Well, this one will be moving downwards, but its overall, the actual acceleration shall be A1 plus A2. That is what is going to happen. That is when this one, A1, the whole thing is coming downwards at A1. But again, relative to A, there is this one. So I guess we're getting what I'm talking about. And now they want us to find those accelerations. What is A1? What is A2? And we need to complete this diagram. There are some forces involved here. We can call this one T1. Call that T1. Acceleration is not supposed to be put in the string. That one is I can just show it is there. So we have T1 here and the T1. There is a weight because of this 3, that is 3G. There is these strings are different now, so this one is T2. We shall assume the tension is in the strings are T1 and then T2. So there is this one, it is T2 because the strings are different. and there is a weight acting downwards here, which is 2g, and there is a weight on this, one also acting downwards, 6g. Not forgetting its acceleration is a1 plus a2. We shall now consider the motion of these particles. Consider motion of there are many things which are moving. This one is moving, the pulley is moving, 6 kilogram mass is moving, 2 kilogram body is moving. So what we are going to do, let us consider motion of the 3 kilogram mass. 3 kilogram load, its motion, it is moving upwards, so we have T1 minus 3g is equal to mass times acceleration, ma. We are using the fact that F is equal to ma. That's what we are going to use. So the mass is 3, the acceleration is a1, and then we have pulley. They said this pulley is light. I don't know how you can have a light pulley, but we are going to use the fact that it's a light pulley. So for motion of this light pulley, we have downward forces T2, that is 2T2, then upward force T1. And since the overall motion is downwards, we assume that the T2, these two T's are bigger than that, so we can have that 2T2 minus T1 is equal to the mass, which they say it is light, so we have mass 0, acceleration a1. This one implies that T1 is equal to 2 over T2. Call this equation 1 and call this equation number 2. Let us consider the motion of the 6 kilogram body. It is directed downwards at acceleration a1, a2. So for 6, this one is 6 kilogram load. We look at that one, we have 6g minus T2 equaling to the mass is 6, the acceleration is a1 plus a2. We call this one equation number 3. Yeah, call that equation number 3. Then look at 2 kilogram load. 2 kilogram load, we are here. This one is moving upwards because it is being pulled in that direction. So T2 is bigger than the weight. So we have T2 minus, this one is T2 minus 2g, getting us 2 into a2 minus a1. Call that equation number 4. We have 4 unknowns, the 2 tensions and the 2 accelerations. And since we have been able to generate 4 equations, we can be able to solve the 4 unknowns. With the 4 equations, you can solve the 4 unknowns. Let's say that from 1 and 2, substitute where there is T1, you put this 2 T2. So we shall have that 2 T2 minus 3g is equal to 3a1, implying that T2 is equal to 3 over 2 into a1 plus g. Put T2 in equation 3. T2 in, this is T2 in equation 3. When you do that, this one is 6g minus 3 over 2 into a1 plus g is equal to 6 of a1 plus 6 of a2. Let's multiply through by 2. 12g minus 3a1 minus 3G is equal to 12A1 plus 12A2. 9 for the G's we have 9G is equal to, there is A1 shall have 15 A1 then plus 12 of A2. You can call this one equation number 5. Then we can also say that equation 3, let's have equation 3 plus equation 4, because when we do that we shall be eliminating the values of T2 such that 4G is equal to the A1s. We have 6A1 and then minus 2A1. So that one is equal to 4A1 plus the A2s. We have this one as 6A2 and that one is 8A2. We can reduce by 4. G is equal to 2. Actually, G is equal to A1 plus 2A2. Call that equation number 6. We can solve this from, let us use the fact that here A1 is equal to G minus 2A2, and substitute this in equation number 5. So we are going to have that 9G is equal to 15 of G minus 2A2 plus this one is 12A2. 9G is equal to 15G. If I work out here 9G and then 15, I'm taking the G to the right, then this one was to the left. So 18A2 is that, such that A2 is equal to a third of G in meters per second squared. Then this implies that A1 is equal to G minus 2 over 3 of G, and A1 is still equal to a third of G meters per second squared. We are getting this one from this one, 2 over a third, that is 2 over 3G. Putting that one there, substitute this one here, and you are getting this. So A1 has been got and A2 has been got. Now when you are to look at, if you are to get the values of the acceleration of the individual ones, this one moves upwards at acceleration a third G. This one, the pulley moves downwards with the acceleration a third G. This one moves downwards with the acceleration a third G plus a third G, that is 2 over 3G. This one moves down upwards with the acceleration a third G minus a third G, which is 0. So this one will appear as if it's not, it will be moving with a constant speed. It will be moving upwards with a constant speed, and it will not be accelerating. It will not be accelerating. There will be no acceleration, and I don't want to say that there will be. It will not be. It will be at rest, because the zero acceleration does not mean being at rest. It may mean that it is moving with a constant speed. So that is, those are the accelerations which they wanted us to obtain. Let's look at this example. They are saying that a string with one end fixed passes under a movable pulley of mass M1 over a fixed pulley and carries a mass, that was supposed to be M2, and carries a mass M2 at its other end. With the system released from rest, show that the tension in the string is 3M1 M2 G divided by 4M1 plus M2, and that after time t, the movable pulley has moved a distance gt squared into 2m2 minus m1 divided by 2 into 4m2 plus m1. We can solve this problem. Let us have a diagram that can enable us solve it. This diagram here conforms to what we have in this question. The pulleys involved are those and the masses. Those are the masses which match what they have given us in diagram. We are going to use the fact that F is equal to MA, and we consider the various objects that are moving. If we consider the motion of the pulley, for the pulley, this is the pulley. For motion of the pulley is moving upwards, so we have T and T, that is 2T upwards, and then minus this one downwards. So you have 2T minus m1g is equal to the mass is m1, the acceleration is a. That one is the first. We can call that equation 1. For motion of m2, this is m2. For motion of m2 is moving downwards, so we have m2 times g minus the tension which is acting upwards is equal to m2 still times 2a, the acceleration. And now we can reduce this to m2g minus t is equal to 2m2 times a. That is the one we shall call equation number 2. When we look at this, you have equation 1 and equation 2. There is 2t and there is t. If I multiply this equation 2 by 2, I shall be having a 2t and a negative 2. So which, let's say this equation 1 plus 2 of equation 2. That one shall be helping us to eliminate the value of t, so that we can get the value of m. So 2 over this, that is 2m2g. That is for this one was the m2. This one, then we shall have up there, that is plus, but this is a minus, so it is plus negative of that one. So that is 2m2 minus m1g. That is what we have on the left hand side, because we have this one plus 2 over this. The 2t, this one is gone, so the t's are gone. Then on the right hand side we have 2 over this, that is 4m2a plus the other one is m1a. Shall have this side 2m2 minus m1 times g divided by what has come up after the factorization of the other one, that is plus m1. That one is now the acceleration. Let's get this acceleration and we put it in this equation here. Let us apply it here. If we put it there, we have that m2g minus t is equal to 2m2 times the acceleration, which is 2m2 minus m1 divided by 4m2 plus m1 times g. What we can do here, we can maybe let's take this one to the left and we take this t to the right. Let all of this chunk be carried to the left. So we have that t is equal to m2g, this one here remaining on the left and this one going to the right. Then minus this is 2m2 into 2m2 minus m1 over 4m2 plus m1g. This one is like having that t is equal to a minus something up over, so we can get the LCM where the denominator is this one here. So what we are going to do, shall have get the LCM and have that T is equal to, this is M2G times 4M2 plus M1, there is a G, this G, then minus this is 2M2 into 2M2 minus M1 times G, everything over 4M2 plus M1. So T is equal to, let us open the brackets. This one is 4M2 squared G plus M1 M2G upon getting this M2G times this M1. Actually, when we have this, actually this G is not there. That G is not there. We are just having this G, which is that. Then this one is minus. If I work out this, I have this one is 4M2 squared. 4M2 squared, and there is a G, that G out there, plus 2M1 M2G divided by 4M2 plus M1. When I work out here, I have that T is equal to the 4M squared G and the 4M squared G, they will cancel. Then M1 M2, 2M1 M2G. So this one is 3M1 M2G divided by 4M2. This is 4M2 plus M1, and that is the tension. And now they want us to find that, to show that the movable pulley has moved the distance, this one. What is the distance moved by the, after time T, what will be the distance moved by the movable pulley? So the movable pulley will move a distance which is given by S is equal to UT plus a half of AT squared. So the distance is what we are looking for. Its acceleration, we have it. We are looking for the time is given as T. So this one is 0 because that one is, it was starting off from rest. So this is a half. Acceleration, we substitute it there. It is 2M2. This is 2M2 minus M1 divided by 4M2 plus M1, then multiply by the axle, there is a G there, then multiply by T squared. And when you work out this, you see that the distance covered, the S is equal to G T squared into 2M2 minus M1 divided by, there is a 2 out there, then 4M2 plus M1. That is the S, the distance covered by that body. And I think it is in conformity with what they have given us up here. So that is how we can handle that stuff there. This is the proof. We have, this one may not be a pulley system, but it is part of connected particles still. You have, let's just say what they are saying here. The figure shows a block of B of mass 5 kg lying on a smooth table. It is connected to block A of mass 6 kg and C of mass 3 kg hanging over the edges of the table by light inextensible strings running over smooth pulleys. Initially, the system is held at rest. Take note of that. After being released, the tension in the string joining A and B is P, and the tension in the string joining B and C is Q. If the magnitude of the acceleration of each block is A meter per second squared, write down the 3 equations connecting A with the P and OQ, and hence calculate A, P, and Q. Then they say that calculate the time taken by A to descend 60 centimeters from rest, assuming that B remains on the table and C remains hanging during this time. That is the question. We are supposed to look at the information which they have given us in the wordings, and we apply it to that diagram. I shall use this same diagram, but we are supposed to redo. We are supposed to copy the diagram, then before we can put our modalities. But I want to use this same diagram here to put the forces involved and even get the equations from there. Then we can solve them from somewhere else. So what we are going to do, we take note of the fact that the tension in the string joining A and B, the tension there, they said that it is P. So there is a tension P there. This one has a tension P. There is a weight 6C. There's a weight of 6G on this thing down. They said it is a smooth pulley, so it is a smooth surface, so there is no friction. This one is a Q smooth pulley. Both sides of the pulley, they have the same tension. So if I'm to look at the tension here relative to the pulley, it is also P. And when we look at this diagram, from the way it is, we are supposed to have an acceleration in that direction, because 6 kilograms, 5, and then 3, this one cannot overpower the other ones. So it should be, if it's supposed to move, then it should be in this direction, the one which I have indicated. If I consider motion of this one, I have 6G minus P equaling to 6A. That is equation number 1. 6G minus C, P equal to 6A. Then we look at this point, I shall have that P minus Q is equal to 5A. Call that equation number 2. Then when I look at this one, it is moving upwards. Actually, there is a weight down here, 3G. So for this, I have Q upwards minus 3G. Q minus 3G is equal to 3A. That one is equation number 3. Now those 3 equations, I have got them. I want now to take them to a portion where we can solve them. I just want to show you how we get those equations, and we are done with the diagram. Our task now is to solve these equations, and we see how we can go about it. When you look at these equations, there are 3 of them, and we have 3 unknowns. And when you have 3 unknowns, you can only solve the 3 unknowns when you have 3 equations. And here we can solve them. From equation 1, P is equal to 6G minus 6A. Let us substitute that P in equation 2. So 6G minus 6A is equal to, actually minus P minus Q is equal to 5A, such that 6G minus Q is equal to 11A. And now after that, we are going to say, call this equation number 4 Then you have equation 4, okay, equation 3 plus equation 4. That's what we are doing. If you get those two equations and you add them, you are trying to eliminate Q. So we shall have that this one and that will get us 3G. Q is gone, is equal to, when I add there, I have 14A. So I shall have that A itself is equal to 3 over 14G in meters per second squared. And if I work out the value of G as 2, I get 2.1 meters per second squared. P is equal to 6G minus 6 of 3 over 14G. This one is 6G, maybe 6G minus 6 times 2.1. And then again, this one is G, 9.8. So I'm going to get P as 46.2 newtons. After getting P, we now have it here that P, use equation 2. Q is equal to P minus 5A. So this is P minus C. I already got P. Maybe I can say 46.2 minus 5 times 2.1, 35.7 newtons. That's the value of Q. They're just solving. Actually, what we are doing is that to solve these equations. You can have, there are many ways you can solve those equations and you get these answers. And then where there is G, you substitute there 9.8. It is in meters per second squared because it's a gravitational acceleration. Now we are going to use the fact that as that point, as that C is moving, as A is moving downwards from rest, it is following this equation. S is equal to UT plus a half AT plus a half AT squared. Because they are saying calculate the time taken. You are looking for time. It was raised from rest. It has covered the distance 60 centimeters. 0.6 is equal to a half. The acceleration was calculated as 2.1, and this is T squared. So we have that T squared is equal to 2 times 0.6 divided by 2.1. T is equal to 0. We are working out with this square root of that to get 0.756 in seconds. That is the time it will take. Now, the only way you can improve, the only way you can make it in mathematics is by practicing a lot. So, after me giving you these basic principles, you are supposed to go and solve all those questions in these exercises. Understanding Mechanics by A.J. Sadler is a good book, and when you try to solve all of those questions which are there at the end of the course, you shall be able to attempt the mechanics questions properly. So we are going to work out you try to work out exercises 3A and 3F. I believe that from the information you got from this video and the rest and some of the previous videos, you can be able to work out all of those questions. And if you have any problem, the Telegram channel is open. You can always raise your concern and try to find a solution. As for now, peace.